Okay, let's look at some review questions from Chapter 6, just to give you an idea of the kinds of things that you should know now that will help you before your test. Here's question number 1. Mercury's surface most resembles which of these? Well, as we look at Mercury's surface, you see a lot of craters. You don't see any maria. So it's it's very cratered surface, kind of looks like Earth's moon, but not the near side of the moon, because that has all those maria areas. So it kind of looks like the moon's far side. So Mercury and the moon's far side are heavily cratered. Craters look smaller on Mercury just because Mercury's bigger. Mercury is very hard to observe from Earth because because it never ventures far from the sun, it being only 0.4 astronomical units away from the sun. At its greatest elongation, it's only 28 degrees from the sun, which is about 2 handspans. So each handspan, in terms of time distance on the celestial sphere, is 1 hour. So it's never more than 2 hours either from the sun in terms of angular distance, and hence the sun is always going to be too bright. So your best chance is right after sunset or right before sunrise, and only when it's near that greatest elongation at 28 degrees from the sun. So that's our answer. How do the atmospheres of the moon and Mercury compare? Well, neither one has an atmosphere, and that's one reason why their surfaces are so heavily cratered, because the objects coming in don't burn up in the atmosphere, they just hit the surface. So neither one has a permanent atmosphere at all. Mercury has extreme high and low temperatures between night and day because it has no atmosphere. There's no mechanism to help mitigate temperature and spread it around the globe. So when it's hot, and when it's cold. There's no mitigation going on. So let's see, which answer is that? It has no atmosphere to moderate temperatures over the globe. Which statement about the rotations of Mercury and the moon is false? Well, the moon is tightly fixed to the Earth, so it rotates once on its axis every 29 days or so, and in the time it takes to go around the Earth. The Mercury is not totally tightly fixed to the sun because it's got an elliptical orbit, so it has that 3-to-2 spin resonance. Let's see what we got here. Then our moon keeps the same. Which of these is false? Our moon keeps the same side towards us. Well, that's true. Mercury keeps the same side sunward at perihelion. That's true. Like our moon, Mercury does not rotate at all, keeping the same side facing the sun. That's not true. It rotates slightly because it's got that elliptical orbit. So that would be false. On Mercury, 3 days equals 2 years. On the moon, each day lasts about 15 Earth days, so we choose this one because it does rotate in 59 days. Which of the following inner solar system bodies has the densest atmosphere? Well, that would have to be Venus, with 90 atmospheres, Earth atmospheres of pressure, causing most of its surface features, or helping contribute to its surface features. The greenhouse effect on Venus is due to blank in its atmosphere. Well, that's due to carbon dioxide, which traps infrared radiation. The radiation that comes into Venus gets trapped in there, causing it to be very hot, both day and night, on both sides of the globe, because it's distributed throughout that atmosphere. So that is carbon dioxide. 900 degrees Fahrenheit. Venus' surface shows all the following except Well, Magellan went around Venus, took a radar mapping, so we see most of those features on Venus. We see impact craters, but not of all sizes, only large impact craters, because the objects that made it through the dense atmospheres have to be large in order to survive. If they're smaller, they're going to burn up. So A would be the exception. We do see shield volcanoes, continent-sized plateaus, circular volcanic coronae, lava domes, so it's A. We do not see all sizes of craters, just large ones. What effect does the greenhouse effect have on the surface environment of Venus? Well, it raises the temperature. It gets very hot on Venus. We have a runaway greenhouse effect. So the surface temperature is several hundred degrees Celsius, and actually hotter than Mercury, which is closer to the Sun, because Venus is trapping all this energy in and keeping it in. So Venus is hotter than Mercury on both sides of the planet. Which of the following inner solar system bodies has the largest volcanoes? Venus has the largest conglomerate of volcanoes, but the largest volcano in the solar system is actually on Mars. Olympus Mons rises more than 25 kilometers above the surrounding plains due to the low gravity on Mars allows that shield volcano to grow and get bigger. Venus and Mars probably evolved differently from the Earth because they're not slightly bigger than the Earth. They're not more massive than the Earth. They have thicker atmospheres than the Earth. Only Venus has a thicker atmosphere. Mars has a much thinner atmosphere. They formed sooner than the Earth. Now they probably all formed about the same time from that solar nebula. They orbit at different distances from the Sun. Earth is in the Goldilocks zone, which is more defined. Venus and Mars are not, so they probably evolved differently because they are further or either closer to the Sun than we are. The weakness of the magnetic field of Mars is because it spins at about the same rate as the Earth does, so it's not that. Its core may no longer be molten. That's very likely. Because if it were molten and spinning like it does, we should see a magnetic field. Its core contains less iron than our Earth. That's very likely too, because the density of Mars is 30% less than the Earth, so it probably doesn't have as much iron as the Earth does, a real heavy material like iron. So both C and B are probable. As it says, both 2 and 3 are probable. So answer is D. What was the most likely source of water that formed the huge outflow channels on Mars? Well, probably the original water came from large comets that struck Mars, just like the Earth got its water from large comets that struck the Earth. At one time, the solar system was much more dynamic than it is now. But these outflow channels probably came much later as frozen water that flowed. So it's probably some kind of catastrophic but rare flooding that occurred from a heating event, maybe a collision or something like that, that caused the frozen water to flow. And that is the end of our review questions for Chapter 6.